Rated 2 column proof. Given segment AD is a diameter of circle O, segment DC is tangent to circle O at point D, prove triangle ABD is similar to triangle ADC. So filling in my statement of reasons. I know my first statement is just always restating the given. So segment AD is a diameter of circle O. And then I also have segment DC is tangent to circle O at D. And this is all given. Well, let's see what that really means. I can see by my diagram off to right that segment AD does in fact look like a diameter. And if segment DC is tangent to circle O at D, I end up getting a right angle. Well, let's see where we're trying to go with this. I'm trying to get triangles similar. And I know to get triangles similar, I'm either going to do side, 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 angle, side, or angle, angle. Well, since they don't give me any side lengths at all in here, I'm thinking that most likely I'm probably going to be having to deal with two angles. So let's get a better understanding of which triangles it is that we're even dealing with. So I'm trying to prove that triangle ABD, so let's outline that here. So I'm going to try to prove that that triangle is similar to triangle ADC. And one of the first things I noticed by looking at these two is they both share angle A. So let's work with the fact that it's probably going to be angle-angle similarity, and I'm going to write down that I know that they both have angle A in common. So angle A is congruent to angle A, and that is going to be by the reflexive property. Now, what other angles can we deal with? Well, I said in the beginning that we know if a tangent intercepts the circle at the endpoint of a radius that we get a right angle. Well, could we get a right angle in the yellow triangle? And here's something I sort of noticed in the yellow triangle. Inside of the yellow triangle, I noticed that this angle here appears to be a right angle, and the reason it appears to be a right angle is it's an inscribed angle which intercepts this semicircle, and I know that an inscribed angle that intercepts a semicircle is going to have a measure of 90 degrees. So I'm really going to have both of the triangles having a 90-degree angle in them. So let's write that information down in our proof. So first I'm going to deal with the angle down by angle D, and I'm going to write the angle ADC is a right angle and the reason is tangents are perpendicular to radii at point of tangency. Then the next thing I'm going to do is write down that angle ABD is a right angle. And the reason is going to be the reason is going to be inscribed angles are half the measure of the intercepted arc. And step 5, I can say that angle ADC is congruent to angle ABD. And the reason is going to be right angles are congruent. can finally state that my triangles are similar. And the reason is going to be by angle-angle similarity.